All right, so I like to get on to the next portion of the Rust book. See what that looks like. I believe it's something about basic concepts. Rustling. And this is how we get to the book again. Go to learn, read the book. Last time we did the programming guessing game. If you have any questions on that, feel free to ask in the comments and I'll get to it. But today we have common programming concepts. This you guys can read on your own. I want to go to the first section. And let's start figuring out what this is. Variables and mutability. All right. Let me bring up an editor as well. Let me move this to this side. Open PyCharm. Rust Charm. What are they going to call the Rust one? They probably got a name for the Rust one, like Rust Go. No, Go Land. I don't know. Anyway, close. We'll create a new project. Call it what you like. I'm gonna call this one variables and mutability. Variables and mutability. Binary project. That's where cargo is. That's the version of the tool chain that we want to use. Everything seems to be in order. Create, use this window. What you notice is when you create a project, you already have your source, you already have your cargo toml file. Get ignores already here. And so is your main. And we're just gonna write everything in main. And just to make sure this runs, let's just do a cargo run real quick to see the hello world. And we got a hello world. All right, now that that's done, let's look over here. What did they have us over here looking at? What is this? Let's see if we can make this a little bit bigger. Maybe make that a little bit smaller. I don't know. I don't think I can get rid of this side portion. And I did. Wow, that's so much better. Okay, so variables and mutability. As mentioned in chapter 2, by default, variables are immutable. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. And they're going to tell us to create a new directory, which we already did, a new project, which we already did, and let's start writing out some of this code, see what it looks like. Add files to get. Ask me later. I'm just going to close that. All right, so let x equals 5, defining a variable using let. And right there it shows us in the editor right here, it shows us what type it is, which is good. Then we could use the print macro like they were using to print out the variable. The value of x is pass in x. And let's just print this out to see what it gives us. Make sure everything's running properly. The value of x is 5, like we expect. So what they tell us in this section is that when you declare a variable, by default it is immutable, meaning you can't change it. So we have, let's try to make x equal to 6 and see what happens. Print the value of x is, finish typing it. Oh, ooh. Before we even get to running it, we see that the IDE is telling us this is a big no-no. We see this red underline? No, don't do this. Let's see. But let's see what the compiler tells us. And it says, cannot assign twice to immutable. variable, which is described in the documentation. All right. So now that we know that is a thing, let's see how to properly do it. So if we want to do this, we can say let x be mutable. And we can explicitly state that x is mutable by typing the mut, I guess, keyword in this syntax of the let. So let's go back here and try to run this again. X is equal to 5. The value of x is 5. The value of x is 6, which is what you typically would expect. All right, so another thing that they tout is the difference between variables and constants. So let's go over here and read that real quick. Being unable to change the value of a variable might have reminded you that of another programming concept that most other languages have: constants. Like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. First, you aren't allowed to use mut with constants. Constants are just immutable by default. They're always immutable. You declare constants using the const keyword instead of the let keyword. And the type of value must be annotated. We're about to cover types and type annotations in the next sections. Yeah, we can skip that. Well, we can't, but we can skip that section, that portion. But let's see how to define constants. So we can just do it right underneath. Their example is saying using const, the keyword which is highlighted, and to say max points, because that's what they're using. Points. For constants, you have to annotate the type. So here we have a U32, which is unsigned 32-bit integer, I believe, which means that it can only be positive, and we're giving it a number. I'm not exactly sure why numbers have underscores in them, but that's kind of curious. Okay, and let's print that one out the screen just to make sure everything working okay. The value of max, I'm just gonna call it max, is max points. Can complete it for me. Thank you, editor. And let's run it. And that worked out just as we expected. The value of max is 100,000. So the underscore between numbers, I guess that does make it cleaner and easier to look at, because now you know where the comma is supposed to be. Okay. So the next concept they would like to introduce is called shadowing. Now, if you just look at here, I'll read it first. Look, as you saw in the guessing game tutorial, which we did in a previous video, you can declare a new variable with the same name as the previous variable, and the new variable shadows the previous variable. I don't know how to say this word. I'm just called Rust people. Rust people say that the first variable is shadowed by the second, which means that the second variable's value is what appears when the variable is used. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. So what they're describing here, and I can start getting rid of some of this stuff here because it is bloat now. What they're describing here is that once we use a variable, let's say define one, let x equals 5, right? By default, we know this is immutable, meaning we can't change it. However, if you want to redefine x, you can. And that portion is called shadowing. So we say let x equals 5. Then we can say, well, let x equal x plus 1. Okay, x plus 1. X is now 6. And we can do this because we're just redefining x. We can also do it again. Let x equal x times 2. All right, and let's print out the value just to make sure everything works as we expect it to. the value of x is, make sure I have x in here. I'm not the greatest with math. 12. Is that what they say here? 12, 12, 12. They also have a 12. The value of x is 12. This is shadowing. Just like we were going through, you define something. Want to redefine, you can redefine it. Want to redefine it again, you can redefine it again. And that process is called shadowing. See, do they have anything else here that's interesting? Shadowing is different than marking a variable as mutable, because we will get a compile time error if we accidentally try to reassign this variable without using the let keyword. By using let, we can perform a few transformations on the value, but have the variable be immutable after those transformations have been completed. Okay, another difference between mutable and shadowing is that because we're effectively creating a new variable, we can use the let keyword again. We can change the type of the value but reuse the same name. Okay, so what they're describing here is two differences between using let and making something mutable. When you make something mutable and then you're trying to redefine it, it has to adhere to the same type. Whereas if you're shadowing, it doesn't, because you're actually redefining that variable. The examples they have are as follows down here. They have let spaces equal space, 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 right? And then, which is type, as you can see, it's a pointer to a string. Let's just call it string. But we can also say let spaces equal spaces dot length, which is now a different type altogether. You can see right here it says usize. The editor is not yelling at us, and the compiler is not going to yell at us either, but it's going to yell at us because we're not using anything. Could not compile, aborting due to previous error. Oh, I have an L here. Warning, finished, but it ran, it compiled. I'm just not using anything explicitly, so it's giving me things. Consider using underscore spaces instead. Warnings. Anyway, the point is, it still compiles because we are shadowing, and when we're shadowing, we can change the type. And to bring this point home, they have another example where they're not using shadowing. They're trying to make it mutable. And here we will get an error. As you can see from the editor, it says there are mismatched types. And if I were to try to compile this, boom. Expected this type, but found this type. And that is the end of this section. So to be clear, we have just gone over only variables and mutability. Yeah. Hope you guys enjoyed it. I hope it was good. Hope it was a learning experience. Thank you for watching.